Choose the cheapest transportation route. Most probably you chose $4 route. Well, the shipping cost is not always the decision maker for the optimal solution. However, to minimize the transportation cost, there are 3 factors that have to be considered to design a transportation model. These factors are: first, customer demand; second, distributor production capacity; and third, shipping cost per unit. The following example will demonstrate and explain how to solve transportation problems and formulate transportation models. As you can see on the following picture, this is a typical transportation problem. You can see on the left side, 2 plants. Plant A has a production capacity of 100 units. Plant B has a production capacity of 300 units. On the right side, 2 warehouses. Warehouse 1 has a demand of 200 units. Warehouse 2 has a demand of 200 units. To transfer units from 2 points, there is a shipping cost. As you can see, the blue route is the shipment route from Plant A to Warehouse 1 or 2. From Plant A to Warehouse 1 the cost is $4 and $7 to Warehouse 2. On the other hand, the orange route is from Plant B to Warehouse 1 or 2. On the upper right-hand corner, you can see a table which demonstrates the previous transportation model. The first row represents the warehouses, and the first column shows the plants. The cells on the middle represent the shipping quantities and costs for each route. Here, we are going to use the northwest heuristics to start our stepping stone method solution for the transportation model. We start from the northwestern cell or the most upper left corner cell, and we will fill it with the highest allowable quantity. However, there are 2 conditions. First, the shipping quantity should not exceed the allowable capacity for the chosen plant. Second, the shipping quantity should not exceed the required demand for the chosen warehouse. And here the quantity should be 100 units. If the demand has been satisfied, we have to move to the adjacent cell and fill it with the suitable quantity, otherwise, we go to the below cell and try to satisfy the demand. And so on. In our case we stepped down and filled the cell with 100 units. Then we filled the adjacent cell with 200 units. After filling the cells we make sure that stepping stone methodology is applicable by using the following equation. Number of rows plus number of columns minus 1 equals number of filled cells. 2 plus 2 minus 1 equals 3 equals number of filled cells. As a result, the stepping stone method is accepted. Transportation cost equals 100 by $7 plus 100 by $6 plus 200 by $5 equals $2,300. The stepping stone methodology is as follows. We go to the empty cell, and assume we will transfer 1 unit in that cell by borrowing it from the adjacent cell. If you do so, you will figure out that the other cells have been affected and the capacity and demand requirement conditions were not met. So, the quantities in the other cells will be changed as illustrated. Now, we check our assumption. 4 minus 5 plus 6 minus 7 equals minus 2. Which means that, the transportation cost will decrease by $2 per unit. The shown table resulted from the previous modification where we subtracted the least number in the negative cells from all negative cells, and added it to all positive cells. As a result, the transportation cost equals 100 by $4 plus 100 by $5 plus 200 by $6 equals $2,100. The previous modification resulted in a new empty cell, which we will measure its efficiency on the transportation cost, by repeating the previous technique shown. Finally, we have 7 minus 6 plus 5 minus 4 equals 2. the transportation cost will increase by $2 per unit. And therefore, we have reached the optimal solution. Now, we will see how to formulate the transportation model. Let Xij equals number of units shipped from plant I to warehouse J, where I equals 1 and 2, with 1 equals plant A, and 2 equals plant B. J equals 1 and 2, with 1 equals warehouse 1, and 2 equals warehouse 2. The objective function is to minimize total cost that equals 7x1 1 plus 4x1 2 plus 6x2 1 plus 5x2 2. Subject to the following constraints shown. And, thank you for listening.